Hello and welcome back. Let's talk about polar coordinates. So we're going to have two videos on this. The first part, this part, will be what polar coordinates are, what they do, and how to translate from polar coordinates to Cartesian coordinates and vice versa. So a lot of us will talk or know Cartesian coordinates where we have an x-axis and a y-axis, and let's say we have a point here at 2, 2. That's very simple. Everyone has seen this before. This has been banged into our brains for probably years now. So, what are polar coordinates? Well, polar coordinates are quite similar. Well, not really. But what polar coordinates do is they give us a new coordinate system where we have a line here coming out to our dot of a length r, or radius, and an angle theta that it makes with the x-axis. And our points are r, theta. So these have lots of real-world applications, like knowing where you are on the Earth, say. We have our Earth here, and at the center we have a radius. The radius is usually always the same, pretty close in terms of percent error. It's very close. But for 3D coordinates, of course, we would need two different angles, theta, and usually we use phi. We could use x and y or whatever we wanted to use. But when we see those types of coordinates, such as on things like Google Maps, you might see like 7.8432 degrees north, something west, or something like that. I'm not super familiar with it, but those are polar coordinates minus the radius, because the radius is always going to be pretty much the same. So, a lot of the times we're going to want to know, how do we translate from polar coordinates to Cartesian coordinates, or the opposite. So all we have to do is we have to remember that our x value is equal to r cos theta, and our y value is equal to r sine theta. Now this shouldn't be super unfamiliar with anybody. We've seen this in the unit circle, except for that r is always 1 in the unit circle, so, you know. What we can now do with that is we can derive this equation. We know that sine squared theta plus cos squared theta equals 1. And so what we can do is basically find that x squared plus y squared equals r squared, so r equals root x squared plus y squared, where x are those. And so those are equations. Now, it might not be super clear to you how we might use these yet, so let's go through an example. Let's go back to our point 2, 2. And let's make this into polar coordinates. Well, we know that r is root x squared plus y squared, so we can find r easily since we have both of these values. This is going to be 2 squared is 4. This is going to be root 4 plus 4, which is 8. That's just 2 root 2. And so now what we can do is, well, we can write our r in, 2 root 2, and we can find our theta now very easily. We can just say x equals cos theta. Let's say that, or sorry, r cos theta. X equals 2 root 2, or our x value is 2 times cos theta. So cos theta equals root 2 over 2. And if we couldn't see this already, this is quite obviously a 45-degree line, or we could say that theta equals pi over 4. So our Cartesian coordinates, or our polar coordinates for the Cartesian coordinates 2, 2, are r is 2 root 2, and theta is pi over 4. So that's polar coordinates. Very easy, very simple. It's things that most of us have seen before, and I think it's decently easy to understand. Next video, we'll talk about graphing with polar coordinates, which is a little tougher, but about the same. So I hope to catch you in that one. We'll also talk about derivatives with polar coordinates. So thanks for watching.